Morning, everybody. Afternoon, everybody. My name is Bruce Momjian. I am a Postgres core team member and employee at Enterprise DB, and I am Armenian, and I speak here a lot. In fact, I'm going to be back in July, so hopefully I'll see some of you again then. I'm looking forward to spending a couple of days in Yerevan. I haven't stayed in this hotel in a while, so I'm kind of excited to be back, and I think we're going to do some sightseeing with the speakers, hopefully, over the next couple of days. This is actually a brand new talk, so that's kind of exciting for me to have a talk that I've never given before. I've written 67 of them. They're actually listed right there on my website. And there's about 140 videos and about 760 blog entries about Postgres. So a lot of stuff there. But always a new talk is exciting because you never know how it's going to go. We have 70 slides in 50 minutes, so we'll see how that chugs along. If we're lucky, we'll finish early, right? We can all go and have some coffee or whatever we want to go. This talk is actually part of a series of talks that I have written about AI. How many of you have seen the talk I did in December at the Armenia user group? Anybody? Wow, okay, that's kind of surprising. Okay, so I did write a talk about Postgres in the AI trenches. That was written sometime last year, and it really talks about generative AI and how Postgres can be used for generative AI workloads. The talk I did before that about AI was about discriminative AI, which is more about how do you use AI to make decisions or categorize or make recommendations, okay? So this is the previous talk I gave at PGDay, the Yerevan meetup in December. You can actually find a recording of that on my website if you're curious. What we're going to talk about now is sort of the follow-on to that talk, which is really about MCP. How many people have heard of MCP? Yeah, I was surprised because when I spoke in December to the meetup, and I just happened to mention MCP off the top of my head because I was sort of studying it at that point in December, and everyone's like, oh yeah, we know what MCP is. I'm like, really? Like, okay, so I'm behind the 8 ball. What I am going to talk about today is specifically how you can use Postgres for MCP, all right? But to do that, we have to do a couple things. We're going to give you sort of a very general idea of generative AI because you missed that talk. And some of the foundational ideas there are necessary to understand the talk. Then we're going to talk about the limitations of LLMs. Everyone thinks LLMs are fantastic, but maybe they are, but there are things it can't do. And that's where first RAG comes in. We're going to explain what RAG does, give you a background about that. And then we're going to go into the meat of the talk, which is MCP. We're going to talk about what is MCP, how it's different than RAG, why it fixes the LLM limitations. We're going to talk about using ChatGPT actually for a pre-installed MCP server it has. I'll show you an example of that. That's pretty simple. Then we're going to create an MCP server on my server at home, and then we're going to actually create a Postgres tool using an MCP server. So again, we're going to start, this is kind of basic. We're going to start from basically the limitations. Why is MCP necessary? What does it do? How do we set it up? How can we configure it? And then finally, we'll use Postgres to do that, okay? I know people are taking questions at the end. I'd love to take questions in the middle, and I'll repeat the question. Does anyone have a question? Okay, great, okay. All right, so generative AI, if you've seen my talk before, the trenches link, again, there is at the bottom. It basically uses training data to record relationships between words. So man and woman, king and queen, banana and apple. It basically looks at patterns of words that appear usually together in billions of lines of text, and it basically records it in these 10,000 dimension vectors. Unfortunately, I don't have to go into the detail of how that works, but that's effectively what generative AI does. It basically, once you've created the vectors for that are part of an LLM, You then use something called an attention block, which basically allows you to generate new text or new images or new movies or whatever you're generating. That's why it's called generative AI, because it's generating something new. Compared to discriminative AI, which is more about looking at the boundaries or discriminative characteristics of various things, okay? So this is the question, what is the capital of France? And again, it runs it through an attention block to get you an answer, okay? And then what happens when you run it enough, you get something called a final attention block. And the final attention block actually represents the answer to the question. So you ask a question, the answer ends up being the last word of the attention block, kind of cool. And then the next word is, again, the next word of the attention block, and it just continues doing that, generating as many words as you can. And it basically runs through these transformers, is what they call them, which is a series of attention blocks. Okay, any questions? I know really fast, if you watch my previous talk, you'll see a lot more detail. Okay. What are the limitations? So we all know LLMs can do these amazing things, but again, what are you really doing with attention blocks and transformers and these vectors? You're basically creating these trained vectors, and then you're effectively generating text with attention blocks, running them through. However, large language models are good at generating text, but they require massive amounts of data to be trained. Okay, that's kind of a given. It's very hard to update the vectors with new training data. All right, so imagine you go through all the documents on the entire internet, and then all the commits of GitHub, and all the source code on GitHub, and all the PDFs that exist everywhere. Imagine you're doing all that, and then you're like, oh yeah, you know, there's some new information, I want to update it. How? Where? What's new? How do you know? Where? Is there a new PDF somewhere? Like, you can see it gets to be fairly hard to do. So that's one of the problems. The other problem is that these vectors that AI uses are imprecise. So you've heard of the term of AI hallucination. That's effectively because these vectors are kind of statistical prediction of word relationships. I know that sounds like a lot of words, but effectively it's just randomly looking at locations of words. Okay, so where do LLMs struggle, right? Because remember, you've trained it on billions of documents, and you've got all these 1,000, 10,000 dimensional vectors, but LLMs still can't do some things. So for example, things like discrete data. So if you have like a bunch of numbers of measurements of the weather, right? Or numbers of measurements of like accounting charges for, I don't know, shipping over a period of time, or price amounts, or again, how do you encode that in a vector that's like in 1,000 or 10,000 dimensions, right? It doesn't really apply very much. It's yeah, you can put the numbers in the LLM, but because you're just statistically sampling these words, you don't really have the precision to say this banana costs a certain amount, or this charger, you know what I'm saying? It's not, you can't encode precision in something that's effectively a statistical averaging in a vector. The other problem is dynamic data, because again, as I said, as the data changes, what do you do? How do you, if price goes up or something, or what do you do, right? And then accuracy. Again, as I said, you're statistically sampling, you have a problem. So LLMs are great at generating text because, frankly, you know, when most novels, most things we read are kind of using the same words, similar word combinations, right? If you sample enough documents, you can kind of fake text output, right? But they aren't completely accurate, and sometimes it does weird things and it says weird things, and you're like, wow. So again, discreteness, where the data isn't really tied to a pattern that the LLMs can record. If the data is dynamic, it's changing a lot, or if you need 100% accuracy, LLMs really aren't going to help you. All right? And I want to apologize to the cameraman because I'm moving around. I'm sorry about that. So thank you for following me. I like moving around. Okay, so one of the solutions to this is RAG. How many people have heard of RAG? Yeah, probably everybody. Okay, so what RAG does is normally when you're in a chat, a generative AI, and you type something, you think that what you're typing is all that goes into the attention block, but that's actually not true. There's actually 3 parts. There's a context, there's restrictions, and personality. All are part of what we call the system prompt. So there's the user prompt, which will you type, and then there's a system prompt that's invisible to you that typically is included before your text. All right, you don't normally see it, but and in fact, if you're in something like OpenAI, you can even go in and you can even edit what that preamble is, that system prompt. You can kind of add some things to the system prompt. So every time you type something in OpenAI, it'll add this little part of the system prompt in the beginning. Okay? So what you can do is you can effectively start to bring some of the precision and some of the limitations of LLMs into the prompt by using this RAG mechanism, right? So I'll give you an example. Here's one. Like, I wanted to tell it to give me a brief output. So I actually added a system prompt called briefly. And every time I type something, when the data goes into the attention block, it goes into the transformer, the word briefly is going to be right before whatever I type. Is that clear? Okay. And when the word briefly is before whatever I type, when I'm doing the vectors and I'm averaging all the vectors that from what I typed, this word briefly is also in there, and it ends up making brief output. Okay. And again, here's what would normally happen. What is the capital of France now becomes briefly what is the capital of France. Okay? So this is one way of affecting and dealing with the limitations of LLMs is I can add some text to the beginning of the query. All right? And that would give me a briefer example. But again, this RAG option has some limitations. Okay? One of the big problems is that we don't actually know what the user's going to type, right? So like when we set up a RAG system, we have to kind of guess what are they going to type. So for example, if I'm setting up a RAG system that I know customers are going to be typing in, I'm going to put in like the location where the customer lives. I'm going to put in the invoices of the customer. I'm going to put in like their recent orders, maybe. Maybe I'm going to put in the name of their salesperson, right? I'm going to put some stuff in there prior to the prompt. Remember the system part of the prompt where I had briefly? I'm going to put some information that I hope is going to be helpful for that customer prompt. That makes sense? Okay. But I don't actually know what they're going to ask. I'm just guessing, and I'm sort of putting stuff at the beginning. So again, it works really well if you have an idea what the person's going to type, but if you have no idea what the person's going to type, it's very hard for RAG to kind of guess what data to put there. It's hard to, the problem is it's hard to adjust the system prompt based on what they type, because you typically have the system prompt, you can look at the prompt, you can look at what they type, and you can kind of stuff some things in the RAG. But again, it's free-form text, so you're guessing at that point, okay? And it can't perform any external tasks unless you've made the RAG do that. The RAG is going to have to go out to the database and get the invoices. The RAG is going to have to go out and get the location of the customer, the name of the salesperson. You're going to have to do all that in your RAG, hoping you guess what useful information is going to be there. And that's effectively the fundamental problem with RAG. And I love, the URL here at the bottom. Anything in blue is actually a URL. And the title of it is 7 Ways Your RAG System Could Be Failing and How to Fix Them, right? So again, walks you through a number of cases where you're like, well, it's not working the way I want. What can I do? Okay. All right. Any questions? Yes, sir.
MCP is a better way of achieving this goal.
We're going to get to that. Yeah. We're going to get to that. What else? Something about the RAG or before, right? Okay. All right. Exactly what this gentleman wanted to talk about. what is RAG doing what is MCP doing that RAG couldn't do? Why is it so popular? Okay. So Model Context Protocol, again, we have some URLs here at the bottom. This is a lovely, the first URL here says, why the Model Context Protocol won. That's a great article. It's on New Stack. And what it basically says is that Claude implemented this MCP thing about, I don't know, maybe 20 months ago. And probably within 6 or 7 months, everybody had adopted it. And now everyone's using it. Okay, so it was this really revolutionary approach to addressing the limitations that I listed here of LLMs. Remember, here's our limitations, right? RAG does some of it if we know what the prompt's going to be. If we don't know what the prompt's going to be, it's really hard. And what effectively happens is that MCP becomes this incredible capability, okay? So Model Context Protocol allows models to retrieve external data and perform external tasks. These are the two things that really bring us a brand new capability. And the operative thing here is it is not some programmer who's trying to guess what data needs to be in the system prompt and is basically writing a program to fill in the system prompt. What actually is happening, and the text here makes it pretty clear, the language model effectively is the one that controls what things get added instead of a programmer. That really is the fundamental difference here. Because RAG doesn't do it something on its own. You have to do it. The programmer has to do it. This allowed basically merge the idea of getting external data with, instead of a programmer controlling it, the LLM controlled it. Like, wow, that you would think, I wouldn't have thought that would have been amazing, but it actually turned out to be amazing. Just the similar way that generative AI, some of the ways they effectively used the mathematics you wouldn't think it would work, but in fact it works really well. So what kind of things can we do with MCP, okay? What was last month's total revenue? Well, that's discrete data. That's really not something we can encode in an LLM. But what I can do is I can tell the LLM, you run through the transformer, and at the end, if you need to go get some external data, I'll show you how to get it. And I'm going to show you how it actually works. It's crazy how it works. Second thing, what's the current weather in Sri Lanka? I don't know. It changes all the time. Can't put that in a vector, right? You got to get it from somewhere. So again, external data, dynamic data. Third thing, what is the price per kilogram of Earl Grey tea? Had some Earl Grey tea this morning. Has to be accurate. Not a good thing for an LLM, accurate, okay? So, 3 things. And then finally, the cool thing also is it can perform external tasks. This is where we start to talk about agentic AI. You can send emails, you can book flights. There's a whole bunch of things now that LLMs can do. RAG couldn't even hope to do that. All right? So I'm going to stop here. Maybe you have a question now. You're good? Next one. Okay. So the point is that MCP does 2 things. It takes RAG and it sort of supercharges it to have the LLM controlling it instead of the programmer. And then secondly, it opens the door for external things to happen that RAG could never do. And I think once I put this all together, it'll make a lot more sense. You'll kind of understand it. Okay, so let's take a look. Advantages of MCP over RAG. Industry standard protocol, added dynamically. Programmer doesn't have to be involved. Again, that's what we're saying. You can iteratively call multiple MCP servers over and over again. And again, we have external tasks that we can do, which is fantastic, okay? Again, same thing, exactly what I said, and we have some URLs here at the bottom. All right, so how does this all work, okay? So here's my You've seen this before. Here's my attention block, right? This is the generative AI part. Here's my text embeddings, my training, all right? But I have some new things over here. Here's my text embeddings. Here's what I've trained. Here's my vectors. Okay, here's my attention block. But I've got some new things over here. I have 3, or is that 3? Yeah. I have 3 registered MCP servers there. Okay? That's all I've added is this orange part over here. So the way the MCP server works is you've got a client, and the client can make a request to the server, and the server gets results back. All right? And then those results can then be fed back into the attention block. All right? And again, these can call functions here, and they can go back. So let me walk through the flow. Okay, what is the weather in Paris? We don't know. Changes all the time. Can't encode it in a vector. So we go, what is the weather in Paris? We run it through. Okay, but remember, we've registered 3 MCP servers. Okay, believe it or not, one of them has the word weather in it. Literally, the description of one of those MCP servers says weather. I'm going to show you exactly some code that actually does this, but right now, just take my word for it. Okay, so one of these has weather. Okay, so what happens is when I get my last word, instead of it wanting to go back to the embedding, it actually goes to the tooling vectors. I know this is kind of crazy. Remember, I told you we have all this training of text embeddings. We have another set of vectors, which are tools. And all those tools represent the text of the descriptions of the MCP servers. So it's like we got our own little text embeddings, but the text embeddings aren't from training billions of vectors from documents on the internet. Those are from the descriptions of these MCP servers. Yeah. I know, there's some URLs that kind of explain it. It took me a while to really get it. But what effectively happens is that the vector that comes out of the attention block, the closest match is not a word. The closest match is literally a tool. So you know what happens? Instead of returning a word, it calls a tool. And that's what MCP does. It calls a tool. The tool, the matching vector for the tool, it calls the tool, it asks a question, and the MCP server returns a result back to the vector, and then we get some text out, and the text goes back as part of the attention block. Remember I told about RAG, and it puts data at the front of the attention block. Well, what I'm doing here is I'm putting the output from the MCP server, literally the weather in Paris that I got from the MCP server, is going in the front of the prompt, and I'm going to run the whole thing again. So instead of saying, what is the weather in France, the prompt's going to be, weather in France is 74 degrees. What is the weather in France? Well, that's easy because it knows. Well, you gave the attention block the answer it needs to report because you got it from the MCP server. Okay? So we get some data here, and then we run the whole thing again, but again, we have the weather we got from the MCP server, and that runs it through, and then hopefully we might need to call another tool maybe. We don't know. Okay, maybe they want, I don't know what they would want. Maybe they want cloud cover. So we go back over here. Oh, okay, there's another vector that's also very close to the output of the transformer. So we're going to now call tool number 3. And tool number 3 is going to be in the front. And now we're going to have data from tool number 1 and tool number 3, and then the same question. And then finally, I think we get a match, and we get a word out, and then we return that word, and then we just keep going. Any questions? So the key is, instead of like RAG, where a programmer puts stuff in the front, we basically register some tools, we describe the tools to the LLM, we create vectors for those descriptions, and then the word that comes out of the transformer, we literally call, we can potentially call a tool. And that's how it, so we actually are using the LLM to figure out which tool to call. I mean, is that like bizarre? It was bizarre to me. It makes perfect sense because the LLM knows much better about the question than the RAG author does, or the programmer who's trying to guess what data to put at the front of the prompt, right? So here's an example. What is the current weather in Newtown Square, Pennsylvania? Okay, and I live in Newtown Square, Pennsylvania. Current weather in Newtown Square, Pennsylvania is 4 degrees centigrade and light winds and snow, a chance of snow. This was done probably in the winter. Okay, and I just asked a question. After I said, what MCP tool did you just use? I'm asking OpenAI, and OpenAI says, I used the web MCP tool, and it's specifically, I used the web search, and I looked up the current time and information in Newtown. The weather is considered fresh real-time data. Can't rely on my, here he is. I can't rely on my, here, there's actually, it's admitting, the LLM is admitting its limitations. It's saying, weather is considered fresh real-time data, so I can't rely on my training alone and must query the web to get accurate conditions and forecasts. Right? So I don't even have to look at my slides, just look at what it's telling you. Right? In short, calls the MCP tool web, it does a search, and it has to do that and explains because the weather changes constantly, must be fetched live. And if you're curious, the system has tools for weather, current news, and so forth. And in fact, I asked you briefly, remember that briefly word? Briefly, what MCP tools do you have access to? And it lists about 12 of them. So OpenAI, time I wrote this, I think it was 4.0 or 5.2 or something like that. It has those MCP tools built in. So when you're using something like OpenAI and you ask a question, you may be getting that information from the LLM. But if it's any of the types of data that we're talking about, it's using the LLM to process your question, but it has to rely also on MCP tools to do that. And it's actually admitting that right here. I asked it, can you perform external tasks? Remember, that's the second thing that MCP tools can do. Remember, get data, perform external tasks. Can you perform external? No, I can't, not on my own. I can't control stuff. It doesn't know how, it doesn't have any built-in external tool things that change anything. Just the way it's designed. It doesn't mean it couldn't, it just isn't designed to do that. Any questions? Okay, all right, now we're getting into the meat of it. And I hesitate to use this example because I'm afraid this is the only thing you're going to remember about the talk, but try and not get too excited because there's a lot more to the talk than the radiation part, but the radiation part's cool, and it's probably what you're going to remember, but that's okay. Okay, so I asked the LLM, what is the radiation level at my address? Knowing it has no idea what the radiation level is because it can't know. Because it told me what tools it has, and there's no mention of the word radiation here. Okay? And certainly not at the address that I live at, right? Because it changes all the time. There's always radiation, there's always background radiation. I mean, it's part of our world. When I'm in an airplane, I'll show you, it gets much higher, but it's always there. I'm just like, there's no radiation here. So yeah, okay, so I said, what's the radiation level? And it says, I cannot provide specific real-time radiation measurements at a precise street address. Like, this is really clear, okay? The level of environment model isn't publicly published for individual users or GPS. It just has to get, it doesn't know. And I think it tried to guess a general area or something. It didn't answer it. It couldn't answer it. It's okay, okay? However, I have a GPS device at my house. It's a small device, about this big. It's about size of like a power bank. Okay, it takes a USB connector. Okay, it's about $60 US, not very expensive. Okay, and in fact, this is the model number right here. Okay, but you can see at this point in my house, the radiation level is 14 counts per minute. That's CPM right here. There's a whole bunch of buttons here, but again, that's kind of all you need to know, okay? So how am I going to get the LLM, OpenAI, to be able to answer a question, what's the radiation level in Newtown Square at my house, okay? That's what we're going to do. I mentioned that we always have radiation. This is the radiation level when I'm in an airplane at 30,000 feet, okay? It's like 20 times what it is. So, like, it is what it is. You get more radiation when you fly. You can't help it. It happens. It's a case of nature. I don't think it's harmful for you because they've done studies about it, pilots and flight attendants and so forth. They don't seem to have adverse effects to it, but it's higher, clearly. There's 3 types of radiations, alpha, beta, gamma. Again, they have different penetration capabilities. My radiation detector does beta, gamma, and X-rays. It does not do the alpha part, which is fine because alpha is so limiting it can't even get through paper. So yes, not something I'm worried about. These are the radiation levels in terms of safety. Okay, this card came with my device. So anything like between we're going to CPM, so 5 to 50 is normal, 50 to 99 is check regularly. Remember when I was in the airplane, it was 200, so high level, closely watch, and find out why. Well, I'm in an airplane, that's why. I know why. And again, if it gets to 1,000, leave the area as soon as possible, and then 2,000, evacuate immediately, report to government. It's kind of interesting. I thought it was interesting. I have this little monitor set up, so if the CPM ever goes above 40, a little like screen comes up in the kitchen, like, hey, something's wrong. Why not? I mean, it's kind of cool, you know. It was easy to do once I had the thing connected, right? How did I connect it? I actually used a Perl script. It's super easy. Once you plug the USB in for the Geiger counter, just remember, this is not the only thing you're going to remember about my talk, right? You're going to remember the rest of it too, right? This is an MCP talk, it's not radiation talk, but it's interesting. So basically, when you plug the USB connector into the side, right here on the right, then it basically becomes a serial device, like a terminal. And you can send commands to it and it gets results back. So what this script actually does is it opens the device as a TTY and it sends a special command called get CPM. And then it actually returns 4 bytes that are packed, and you unpack them, and then you get the CPM measurement currently on the screen of that. So you're pulling it right out of the device. So you don't have to do anything fancy, just like, I think every 15 minutes I just query this thing. It's kind of cool. But we're here to figure out how we can get OpenAI to use this. So what we're going to do is we're going to install something on my server called FastMCP. FastMCP is a Python library which effectively allows you to create really easy MCP servers. Okay? We're going to write a Python script to call the Geiger counter. We're going to start the MCP server and we're going to test it. And then the big thing is we're going to register the MCP server with ChatGPT. All right, so let's see how that works. There's a lot of slides here. We're going to pip install FastMCP into a virtual environment called VMs, Python virtual environment. Okay, we're going to create. This is my entire Python MCP server, the whole thing. I call Python at the top through a virtual environment, FastMCP. I import subprocess so I can call a program. I name my server. This blue part is the most important part of the entire script. Anyone want to know why? Tell me why. Yeah. That is the description, exactly. That is the description that goes into the LLM. That goes into right here. Tool embedding vectors, that description goes in there. And the only reason it's going to call this MCP tool is because the vector that comes out of the attention block is going to be very close to that vector. okay? So yeah, that part right there is very keen. And then I actually have a little like temp little file I'm calling that runs it. And I'm going to start on port 8090. So that's what it looks like. There's the fast MCP server. As soon as I started from the command line, it looks like that on Debian, okay? So I had to modify my Apache config. So I basically said, hey, if any request comes in, okay, on MCP, I want to reroute something that's coming to /MCP. /MCP, I want it to go to this special port number. So I'm doing what's called a reverse proxy, which effectively says, if anyone asks for MCP on my web server, because I'm running a web server, I want it to go to here, to my fast MCP server. So I'm kind of routing it through there, okay? Here's how I tested it. You can actually use URL, and you basically create some JSON, and you say, okay, I want to initialize my MCP server. I want to get the session ID, because you have to have a session ID when you use MCP. This is maybe too detailed for you, but I wanted to kind of show it to you. So again, we're going to get a session ID that we're going to use in my testing. So I'm going to export that variable right there in pink. So now I'm going to basically say, list my tools, okay, using my session ID, and it's going to list tools Geiger counter with a description of that. All right, I haven't installed it in OpenAI yet in ChatGPT. I'm testing it from the command line first using CURL. Okay, we're that like raw here. Okay, I can call the tools call, and when I call the tool, bingo, what do I get? 14. Wasn't that what was on my screen back here? 14. Ooh, that's cool, right? So that's exactly what it's doing. And now that I've tested it from the command line, I can now use it and install it in ChatGPT. So I go to ChatGPT console, okay, and I want to register my MCP server. So remember I said if I go to /MCP, it's going to call my special fast MCP server on 8090. Well, that's exactly what I'm doing, is I'm saying go to momjian.us/MCP. It's going to route through Apache. Apache is going to do its reverse proxy. It's going to send it to my MCP server, okay? I don't have any, there's no security. This is just obviously a stupid example, but you get the idea, okay? And now what I basically have is one MCP server, okay, with an Apache server in the middle, and then here's my MCP client. My Apache server, it's going to route going into 443. Apache server is going to go to 1090. It's going to send that data back like that. So now I have a communication channel, okay, from OpenAI. Now, what is the radiation level at 13 Roberts Road? I ask again, and it gives me the same lame answer. That's not good. Look what I added. All I had to do is add a little text to the beginning, use my custom app. In OpenAI, MCP servers are called custom apps. I don't know why. Probably because they didn't invent MCP, so they called it something else. Use my custom app. First thing it says, tool called. The live radiation reading at 13 Roberts Road is 14 CPM, and it gives some analysis. It says it's typical, between 5 and 25. Level is safe. And it can convert it to other units if I like. Okay? So what we did is gone from the case where OpenAI had no idea, ChatGPT had no idea what the radiation level was like at my house, to now it's actually able to answer that question. Because I created an MCP server, I routed it through Apache, and I registered it with OpenAI. And I had to tell it specifically to use it because I said, briefly, why did I have to specify that my custom app should be used? And it literally comes back and tells me, because I don't automatically use custom or external apps unless you explicitly tell me to. Okay. Not everyone has to do this, but that's what they do. That's okay. They don't use it by default. Okay? It's basically saying, when you first ask, I default to public information. Say, use my custom app to tell me to call the custom MCP. Kind of cool.
If you register to MCP server,
Uh,
so that you customize, there is always way to, because like if you register two MCP servers, now what is the name of the, like,
Okay, the question is, if I register two MCP servers, how do you figure out the name? Well, there's two questions to that. I can register two MCP servers, or I can register one MCP server with multiple tools.
yeah, two MCP servers.
If I have two MCP servers, they have to be on different ports. And I just register them as two custom apps in MCP. But the next example shows you how to create two tools in the same MCP server.
Yeah, I know it's possible, but what I mean it's kind of weird for me, like it's not allowing to, when you are adding MCP server, not allowing to define your own name. So now you have more meaningful name to say, okay, use my radiation app or use my...
I could, yeah, I'm sorry, yes. So he's saying, I could have said use the Geiger counter app. I wanted to show you it would know to use that one. So you're right, it would have figured it out. Yeah, I didn't want to give it too much information. Yeah, good point. Other questions? Okay, let's go into the last section. Oh, this is kind of cool. Take 5 measurements and give me an average. So it just basically runs it. It knows to call it 5 times, right? And it gets different numbers because that's what radiation does, and it gives me a cool average. It's kind of cool, right? So it knew to call my cool 5 times when I said take 5 measurements, okay? All right, let's get Postgres involved. The reason I use this picture is these are pretzels up here, yeah, from like, I don't know, 18 something, 17, 16 something, Job Ostrazen, and it's the baker. So anyway, the MCP tool is going to be about pretzels. Kind of cool. Okay, so we're going to create a database called MCP in Postgres. We're going to create a user called MCP in Postgres. We're going to connect to MCP, and we're going to create a pretzel table, which has one column. It just has quantity. I realize this is completely ridiculous, but we did radiation. Now we're going to go simple. Okay, so we just create one table with one column, has a quantity. Quantity can't be less than 0. And we insert 0 in because we have no pretzels at all. We don't start with any pretzels in our store. And we actually grant MCP the right to all rights on that table. Any questions about this? It's a dumb example. One table, one column. All right, in Postgres. Good? Okay. Now, what are we going to do? Oh, wow. Okay, now we're going to create an MCP tool. Okay. Same way of invoking it. Okay. We have to describe it. This actually has 3 different tools inside one MCP server. The first one, get pretzel inventory. That's the name of the function. Okay, it returns an integer, and this blue part, which is the part that's going to go into the tool vectors, says return the number of unsold pretzels. All right, and then we actually have when we call this function, what it does is it does a select from the pretzel table. It just tells me it's one row, one column. Well, how many pretzels do I have? Right? Pretty cool. I even use PSQL. I didn't even use libpq. We're really easy here. Okay? Second tool, sold 1 pretzel. Description, call this when a pretzel is sold. It reduces the number of sold pretzels by 1, and success returns update 1. That's kind of cool. And what do I do? When you call that function, it says update pretzel, set quantity equal quantity minus 1. And the database is MCP. Okay? And then we have a third tool, baked 6 pretzels. Call this when a tray of 6 pretzels is baked and ready for sale, return success, update 1. And what it does is it updates it and increases the number of pretzels by 1. Okay? And we're running it on port 8090 like before. Any questions? Good? Okay. All right. Yep. Oh, I'm sorry, Alicia. Yeah.
I just wanted to ask, if you've got this query, right? Update pretzel, for instance.
Yeah.
Yeah, thank you. So this is like the exact query that LLM will use, or is it like just the template of the query it should
So
use
the-
and it can change it?
Okay, so the LLM never sees that query.
Okay.
All it sees is the description. And it just calls the function, and the function runs the query.
Okay, so it's not going inside to this.
It doesn't know.
definition.
The
Okay.
way MCP works is it just gives the client, the MCP client, the name of the function and the description. That's all it gets. It doesn't see this SQL at all.
Okay.
Okay, this SQL is run locally. It's not run on the. It's not run in the LLM or anything. It's just calling a tool. And the way the protocol works, you get the name of the function and you get the description. And you decide, the LLM decides I want to call that function or I don't want to call that function. We're not passing parameters or anything like that, Alicia. This is just, this is dumb simple, yeah.
But technically, the MCP contains three parts. It's the resources, tools, and prompts. So it's exposing three things. So if you write like more generic things, okay, here is tool to execute queries, and if in resources you are exposing like your database structure, so when LLM trying to see okay, you are going to query this thread cells, so he will call resources, he will get your database structure.
No. We have we're not giving it any database structure. It can't run a query.
It can do it itself.
That would be the next talk.
Yeah, okay.
Yeah, that would be the next talk.
Okay.
I'm thinking of the next talk being, can AI write SQL? That's what I'm thinking. That might be my next talk. But this one is super simple because all it really knows is the title and the description. That's all it knows. Because I have no security on this thing either. There's no security. It's just open to the internet. So I wasn't going to do anything fancy, right? So again, 3 tools. So now I can go to OpenAI and I can say, using my custom app, I know I need to say that, right? Because we indicate we have to. How many pretzels are available for sale? Tool called, your app currently shows 0 pretzels for sale. That's cool. I got a store going. I love this. I just baked a tray of pretzels. I didn't tell how many. All right? I just baked a tray of pretzels. Please update the inventory. Tool called. Nice. Tray of 6 pretzels has been added to the inventory, and now you have 6 pretzels available for sale. I sold 2 pretzels. Please update the inventory. Got it. I've recorded the sale of 2 pretzels, and now you have 4 pretzels remaining in inventory. I sold 4 pretzels. Please update the inventory. All set. I've recorded the sale of 4 more pretzels. You now have 0 pretzels remaining. Time to bake another tray. Kind of fun. I sold 1 pretzel. Please update the inventory. Well, we know that's not possible, don't we? Remember, I put a constraint so it can't be negative, and it would have probably figured that out way. I attempted to update the inventory, but the system returned an error from the database. The sold 1 pretzel command failed with a database execution error. A follow-up attempt to check inventory also failed. It appears the database, anyway, it's confused. It doesn't know what's going on, okay? And if I look at my MCP server, the display, it might be hard to see. I'm sorry about that because it's all black. But it's basically saying it raised an exception because it got a constraint error because it tried to make it negative and it couldn't and throw an error, okay? So obviously, this is a complete stupid example. Okay, what did I not show you? It was a simplistic, call the appropriate function. I've not shown MCP authentication, because again, we had none. I didn't show any parameters to the MCP, like Alicia asked, it's just buy a pretzel or bake a tray of 6. That's all you could do. Because as soon as you allow the MCP, the client to send numbers to your function, then all sorts of security issues become available. So I didn't want to deal with that. I'm going to bake 6 pretzels. I'm going to sell them 1 at a time. Let it figure out how to sell 2 pretzels. It figured it out, right? It called sell 1 pretzel twice, right? And I didn't do anything with dynamic SQL or anything like that. And that might be my next talk. So the goal of this talk was basically to show you why is MCP important, why is it really in a lot of ways superior to RAG. It's similar to RAG, but more powerful because it can pull dynamic data, it can pull accurate data, and it can also perform external actions, which is what I was trying to show with the pretzel example, okay? So again, thank you very much. I'm not going to take any questions because we took questions as I went. I think it been a great conference, super high quality talks, had a great time. I appreciate everyone who's come from outside the Armenia to visit us. It's kind of great to be together in Armenia because I'm normally here like kind of alone with my wife, so this is really neat. I'm going to bring Emma back to kind of close the show. Thank you.